Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover section hyperbola. Okay, so here I have a photo of hyperbola. Okay, so the components that we have in a hyperbola is firstly, you can see this horizontal axis. Okay, the x-axis is the horizontal axis, and the horizontal axis is actually passing through the locus of the hyperbola. As you can see, this is the line of the hyperbola. The green line is the hyperbola, and the x-axis is passing through the hyperbola. So this line will be called as the major, or also known as the transverse axis. Okay, so this hyperbola, where the center is at the origin, C right over here, 0, 0, and the vertical line that is placed in between of the two hyperbola is called as the conjugate axis. Okay, so that is about the axis that we have in hyperbola. And so this hyperbola have its focus right over here. This is the focus for hyperbola, and at the edge of the line here, there will be the vertex for the hyperbola. Okay, there are only two vertex in hyperbola. Okay, so as the same as for ellipse, so the distance from the center to the vertex, the center to the vertex is known as the length of A. Meanwhile, from the center to the focus is known as the length of C. Okay, so for hyperbola, as you can see, now the length of C is way longer than the length of A compared to the situation for ellipse. Okay, in ellipse, as you can refer back, the length of C is actually shorter than the length of A. Alright, and then from the center to this point, okay, this point is the length of B for the hyperbola. Okay, so what's important in the hyperbola is to identify this box in the middle of the hyperbola. Okay, because your hyperbola will be depending on where does this box ends. Okay, and then one more thing, from the edge to another edge of the box, there will be the line of asymptote. So total there will be two line of asymptote, one with a positive gradient, for this one, positive gradient, and another line of asymptote will be this one where it has a negative gradient. Okay, then so for the equation of C, okay, we know that C is from the center to the focus. So that means we will have the length of C that is equal to the length from on top of B to the vertex. This is the length of C. So now we have a right angle triangle right here. So we can say that C square equal to A square plus B square. Okay, then for the equation of asymptote, okay, for the equation of asymptote where the gradient is positive, that will be y equal to bx over a. Then for the asymptote where the gradient is negative, that will be y equal to negative bx over a. And then we also have the lattice rectum for hyperbola, that which is here. Then the equation for lattice rectum is 2b square over a. Okay, so now let's refer to this website, Geogebra. Okay, so here I have a lever for to change the level, the length of A, and another here I have the place to change the length for B. Okay, so now firstly I want to place my A equal to 3 and my length of B is also equal to 3. Okay, so the vertex of my hyperbola will be depending on the position of A. So if I make A longer, so you can see the hyperbola is actually becoming wider, and meanwhile if I change the value of B to be higher, so then my hyperbola will becoming taller. So that is how, that's what important lah, to determine the size of your hyperbola is the value of A and B. Okay, so this K is actually just moving the center of the hyperbola. So this will be the center of the hyperbola at the position of HK. So right here is the place to change the position of x-axis. Okay, so this is one kind of hyperbola where the transverse axis is horizontal, and now we have another type of hyperbola where the transverse axis is vertical. Okay, so this is a second type of hyperbola lah, where it's opening on the vertical axis and also have the value of A and B. Okay, the A is still the length for horizontal value, and B is still the length for vertical value. So now we already know there are two types of hyperbola. Okay, then the equation for parabola. So for the parabola on the left side, where the major axis is horizontal, then the equation will be x square over A square minus y square over B square equal to 1. Okay, the difference is that now we have a negative in our equation. So you can identify if the negative is with the y, so then your major axis will be in the orientation of horizontal. Then for the second type of hyperbola on the right side, the equation will be negative x square over A square plus y square over B square equal to 1. So now the negative sign is with the x. Now your major axis is in the orientation of vertical. Okay, so now let's test by answering this example. So we are given with one equation of hyperbola. Now we want to find the foci, the coordinate for the foci. Okay, so to find the coordinate of the foci, what we have to do first is to find the length of C. So in order to get the length of C, we have to find the A and B. So A in this equation will be square root of 16, that is 4. B equal to square root of 9, that is equal to 3. So our C is equal to 16 plus 9 square root equal to square root of 25, and we have C equal to 5. Okay, so based on our hyperbola, since the negative sign is placed with the y, so then our hyperbola will be in this orientation where the major axis is on horizontal. Okay, then our focal point will be right here. So this will be the length of C from the center. Okay, so now that means we have the position of our foci is 5, 0 and negative 5, 0, which is located right here. Okay, now let's move on to the next question. For question B, find the equation of asymptote. Equation okay, so for equation of asymptotes, the equation will be y equal to positive negative bx over a. So since our b is equal to 3, so we have 3 over 4x, and another asymptote will be y equal to negative 3 over 4x. Okay, here is the next example that we have. We want to sketch the graph of hyperbola from the given equation. Okay, so now we take this equation. We determine firstly the ABC. So a equal to square root of 9 equal to 3. Our b is equal to square root of 4 equal to 2. So then our c is equal to square root of 9 plus 4 and equal to square root of 13. Okay. So now we have A, B, and C. We can proceed with the sketching. So this is Y and X. So the center of our hyperbola is at the origin. And we have the length of A is 3. So this will be the A. And here will be the negative A, negative 3. And like up here will be 2. And down here is the length of negative B. That is negative 2. Okay, so from that, we draw the square of the hyperbola that will help us to determine the position of vertex and the line of asymptote. Okay, so from the edge of the square or maybe a rectangle, we create a dot line for the asymptote of our hyperbola. Okay, so that is for asymptote with negative gradient, and here is another asymptote with, here is the negative gradient. The first one is the positive gradient, and from that we can sketch our hyperbola. This is the vertex, so the vertex come out and produce a line that is approaching the asymptotes. And do the same thing on the other side. Okay, I think you can draw better than this lah. Okay, so from here we can sketch the position for our focus. That will be at the inside of the hyperbola. So the focus right here, the position is negative square root of 13 because the length of C is square root of 13, 0. And the right side will be the positive square root of 13 and 0. Okay, so this is our sketch of the hyperbola. Okay, so the asymptote will be equation of asymptote. Since y equal to positive negative b over ax, so the equation will be y equal to b is 2 over 3x and y equal to negative 2 over 3x. Okay, so make sure that you mention the equation of asymptote in your graph. So here is the positive gradient, and right here is for the negative gradient. Okay, so here is the next question to sketch the hyperbola. So we are given with x squared minus y squared equal to 5. So firstly, we make the right side of the equation become number 1. So x squared over 5 minus y squared over 5 equal to 1. Okay, then we can say that our a is square root of 5, b equal to square root of 5, and we can find the value of c equal to square root of 5 plus 5 and equal to square root of 10. So that is the value of c. Okay, now we can sketch the hyperbola, the y and the x. Okay, the length of a is square root of 5. So on the left side will be negative square root of 5. The vertical one will be the square root of 5, and the down one will be the negative square root of 5. So this is our square at the middle of our hyperbola. Okay, so from that we sketch the asymptote, the positive gradient of asymptote, and here will be the negative gradient of the asymptote. Okay, so we take this point, that will be the vertex of our hyperbola, and another vertex at the left side. Okay, so that is our hyperbola. So now we point the position for focus. This is our focus, and the coordinate will be negative square root of 10, 0, and on the right side will be square root of 10, 0. So now that is the sketch of our hyperbola. Okay, then for the asymptote of this hyperbola, y equal to plus minus b over ax. So it will be y equal to x and y equal to negative x. And make sure you label this equation of asymptote in your graph. So D here it will be y equal to x, and right here will be y equal to negative x. Okay, now let's move on to the next section, is to transform general form of hyperbola into standard form. So here I have an example of general form of hyperbola. So we want to change it into standard form also by using the concept of completing the square. Now we have x squared minus 6x minus 2y squared minus 4y equal to 11. So just the same thing that you do for ellipse. And now we factorize, sorry, not factorize, but proceed with the completing the square. Firstly, for the x, plus negative 6 over 2 square, and then for the y we factorize out the negative 2, then it will be y square plus 2y plus 2 over 2 square equal to 11 minus 2 over 2 square. Alright, so we can simplify this one. It will be x minus 3 square minus 2 y plus 1 square equal to 18. So now we are a little bit closer to change it to standard form. What we need to do next is to change the right side to become number 1 by dividing to itself. So it will be x minus 3 square over 18 minus over 9, and we have it equal to 1. So we have now completely changed this general form into the standard form. Okay, so now from this standard form of hyperbola, we want to find the vertices, foci, and equation of asymptote of the hyperbola. And now we want to sketch. Okay, so we firstly determine the value of a and b. So a equal to square root of 18, b equal to square root of 9, that is equal to 3, and our value of c equal to 18 square, sorry, not 18 square but 18 plus 9, and now we have it equal to square root of 27. So that is the value of c. So now we proceed with the sketching of the hyperbola. So this is y and x. Okay, then for this kind of ellipse, you can see from the equation x minus 3 in a bracket of square and y plus 1 is also in a bracket. So that means the center of this hyperbola is not at the origin. So to find the center, we take x minus 3 equal to 0, x equal to 3, and now we have h equal to 3, y plus 1 equal to 0, y equal to negative 1, and k is equal to negative 1. So this is the center of our hyperbola at 3 and negative 1. So here will be the 3 and here will be the negative 1. So here is the center. Okay, so from the center, we go to the right by the length of A, which is the square root of 18. So that will be 3 plus square root of 18, and to the left will be 3 minus square root of 18. Okay, then go to above by 3 points. So that's mean we will have right here equal to 2, and down here it will be equal to -4. So this is the rectangle in the middle of the hyperbola. Okay, so from that we sketch the asymptote, the positive gradient, and here is the negative gradient. And now our hyperbola will be in the position of like this. And also on the left side. Okay, so our position for focus is 3 plus square root of 27 negative 1, and on the left side will be 3 minus square root of 27 negative 1. Okay, so since the equation want you to find the vertices, foci, and equation of asymptote, so what you need to do is to mention, okay, is to mention clearly about the vertices. So the vertices is at 3 plus square root of 18 negative 1 and 3 minus square root of 18 negative 1. Then the foci is at 3 plus square root of 27 negative 1 and 3 minus square root of 27 negative 1. And then for the equation of asymptote, since the equation for asymptote is should be written like y equal to plus minus b over ax, and since this our equation of hyperbola is given x minus 3 over 18 square y plus 1 over 9 square equal to 1. So we have to substitute the y component to be y plus 1 equal to plus minus b over a. So b is 3 over square root of 18, and our x component become x minus 3. Okay, then we can simplify. Plus minus 3 over 2 square root of 3 square root of 2 x minus 3, and bring it to the left, 3 square root of 2 y plus 1 plus minus 3 x minus 3. Okay, so then we can remove this 3, and our final answer for asymptote is square root of 2 y plus 1 equal to plus minus x minus 3. So that is our equation for asymptote. And we take that equation and label it on our graph. So for the positive gradient of asymptote, we label the equation square root of 2 y plus 1 equal to x minus 3. And for the negative gradient, square root of 2 y plus 1 equal to negative x minus 3.